Hi, everyone.
Hi, Professor. This is Karen. I have a question. I couldn't access the new quiz. I didn't see it there.
Oh, chapter 8.
Yeah.
Let me take a look and see what's going on. Oh, okay. Nice. So we have only one section to cover today. That section is 9.2. It's very short. I believe we only have, let me just double check here. It looks like 4 examples, technically not even 4 because more like 3. So it should be a fairly quick lesson, and then I'm gonna give you some time to catch up on your homework and on your quiz for chapter 8. And
Please do.
today, and within 10 minutes of my letting out. I'm kidding. It's you have a. I think I usually leave them open till the end of the term at this point.
Yeah, they've all been like that so far.
Okay, thank you.
Yeah, just give you enough time, and you get 3 attempts, so it's not like you're gonna die in terms of stress. Should be good. It's pouring by me. Is it raining by you guys?
It started pouring really bad, like a
Yeah,
couple
it
minutes
did.
ago.
I was pressure cleaning up to about a few minutes ago, and then the rain just came down.
Yep.
So much for my efforts.
I wonder when it's gonna stop. It's been raining for like a month now.
Yeah, it's been a rainy season, and I guess that's good. It's better than not rain. Are you able to see it now by chance? The quiz for chapter 8? It might be out of order per se, but
It just showed up.
okay, perfect. Okay.
I did not see it there before, but it just showed up.
No, it was me. It was something on my end.
Oh, no problem.
All right.
Thank you. Thank you so much.
You have 3 attempts on the quizzes. So if you haven't done well on the quiz, please go back and try again. Like I said, today's lesson is very short. It's only 3 examples. If you want, I could do a second session and really push us forward. You tell me. What would make you happy? What would work for you?
Finish the homework.
Okay, so let me finish 9.2 so we stay on track. And after 9.2, which is very short, you can finish the homework. The second one coming up, actually, let me look that up because I had that in my possession a minute ago. Okay, so just let's get a schematic of where we are. Let me share my screen so you could see the paper I'm bringing up. Pacing guide. And that's good because I was worried that I wouldn't have enough time to cover 10.1, 10.2, 10.3, and so on. All right. Okay. So here we are. Yeah. So today I'm doing 9.2. 9.3 is matrix operations and applications, not long either. I could do that one also. We still have an hour. What do you say?
Chapter 8 quiz is the one you just posted up, right?
Correct.
Okay.
So what's your take? Tell me verbally. 9.2 is definitely being covered today. It's very short. 9.3 would be next. And again, I'd still be done within the hour.
9.3 is okay with me.
Okay, so far 9.3. We go. Do I get a second? Yes.
Yes.
That's fine.
All right, cool. Let's do that. Awesome. That gives us a little bit of time also for you to catch up. So let me take myself off video. And am I sharing my screen? Can you
Yes,
see
you are.
my notebook? You can?
Yes.
Okay, perfect. All right, let me. All right, so this is more of what we did yesterday. So just for the record, 9.2 is a continuation of this. Now, when we learned systems of equations, you remember we always look for one that has a solution, which is, we call it the one solution, right? And then we have two others. This is what the next lesson, this is in essence 9.1 in terms of what we just did. 9.2 talks about the others, the two others. So we have no solution, or the null set, or they have infinitely many solutions, which is the same line over itself. So that's what the difference is between 9.1 and 9.2 in terms of what we cover. So example 1, and this can be frustrating given that you just learned 9.1 for most of you. And some of you are, I don't know how you did on the homework, I haven't checked it yet. But I know that, you know, these questions are not, they don't take, 1 second to do, they take a few minutes. So in example 1, you have a system with no solution. So this is the parallel lines, right? So if I have a system with no solution, here's what happens. We're going to follow the process that I showed you, where we solve for the variables. We have to come up with the augmented matrix. Okay, and so what you're looking for here and you're going to see where I do this, what's going to happen right away. We're going to follow the same rules that we learned yesterday. So we start with the augmented matrix. We're going to start with, in this case, 1, -1, -2, 2. And then we have the 2, -3, a 6, and a 5. 3, -4, +4, and a 12. Okay, so we start with step 1, the augmented matrix. Now we want a 1 in this position and we're good. We don't have to do anything. So we don't even need to row swap. So our next 2 points of contention are the row 2 and row 3, because I want those to be zeros. And so if you think about the easiest way that I can do that is I'm going to take, in this case, I'm going to start with, let's see. Let's go with -2 times row 1 plus row 2 for this one. And for this row, I'm going to do -3 times row 1 plus row 3. And so what I end up getting once I do that, all right, so my new matrix, I'm gonna do it over here in purple. So the 1, -1, -2, that doesn't change. But our row 2 is -2 times 1 is -2 plus 2 is now 0. That's what I wanted. -2 times -1 is +2 minus 3 is -1. -2 times -2 is 4, and 4 plus 6 is 10. -2 times 2 is -4, and -4 plus 5 is 1. Okay, we repeat that process now for the third row. I'll do it in red to follow along. So we have -3 times row 1 is -3 plus 3 is now 0. -3 times -1 is +3, and +3 minus 4 is -1. -3 times -2 is 6, and 6 and 4 is going to give me another 10. Do you already start to see a little bit of a connection here? Do you see what's happening already?
You're getting the same values.
You're getting the same values, correct. And so at this point, we already start to question what's happening. Fine. We now need to work on this -1. We want that to be positive. So if I multiply this entire row, -1 times row 2, that's going to become my new matrix, which is now 1, -1, -2, 2, that doesn't change. -1 times 0 is still 0. -1 times -1 is now +1. -1 times +10 is -10. And -1 times 1 is -1. My next point, so we're good there. My next point of contention is going to be focusing here, making this a 0. I need that to be 0 in the green, so I'll follow you here. So I'm going to take this row and let's do -1. Let's see, in this case, I'm going to do 1 times row 1 plus row 3. I'm sorry, 1 times row 2 plus row 3. Okay, so if I do 1 times row 2, so I'm going to end up with 0, 0, 0, 5. That's what happens when you apply this formula. Do you see a problem here? How can 0x plus 0y plus 0z equal 5? That is not possible. So that means that this is an empty set. Okay, so you do the same process. You're still trying to solve for the first position, second position, third position, fourth position, fifth position, sixth position. But what changes here is by the time you get here, you can't even use back substitution because you don't have a variable that is equal to anything significant. Do you want to try one before we move on? Or do I continue? No? Continue?
I think it is easy enough. It's just the logic of doing the math, the substitutions, and the multiplications.
Right.
But the system itself is the same.
Yeah.
It's
The
just
process is
disappointing
not
that
gonna
you
change.
just. It will be
Process-
disappointing you just working through something and just realizing that it has no solution at the end.
Right, so this is a no solution. Like I said to you, the ones we've been working on are one solution. We just did this one. The next one is infinitely many solutions. Okay, so this is example 2. In example 2, we're going to do a system, solve a system with an infinite amount of solutions, infinite number of solutions. Okay, so they're going to give us the following one. And so this is the same line over itself. So in essence, that's why it's infinitely many solutions. So we have 3x minus 4y plus 4z equals 7. We have x minus y minus 2z equals 2. And we have 2x minus 3y plus 6z equals 5. What's going to happen here is that you're going to get typically all zeros at the end. So we start with the same process. We start with the augmented matrix. So we're going to start with our 3, negative 4, 4, and then 7. We have 1, negative 1, negative 2, 2. We have 2, negative 3, positive 6, and 5. So this is where we start. So this one I would want to swap, right? So I would begin here by saying, okay, I'm going to swap row 2 and row 1. So if I swap them, I'm going to start with 1, negative 1, negative 2, 2. I bring my row 1 down, so 3, negative 4, 4, then 7. Here's your 2, negative 3, 6, and then 5. Okay, so we want to zero out row 2. So if I want to zero out row 2, I'm going to do negative 3 times row 1 plus row 2. And for this row, I'm going to say negative 2 times row 1 plus row 3. Okay, and now once I do that, my new matrix now should look like this. We still have 1, negative 1, negative 2, 2. We have 0, negative 1, 10, 1. Already you should start to see and have a question mark about what's going on. You see how the second and third row already match? Okay, and I took care of that position 1, 2, 3. Now I want to focus here, and to do that, I'm going to say, okay, I need negative 1 for this, negative 1 times row 2. That'll make that a 1. This ends up giving me, in this case, I have, okay, so I still have 1, negative 1, negative 2, 2. This time I have 0, 1, negative 10, negative 1. Bottom row does not change because I haven't done anything to it. Okay. Now, if I want to replace row 3, I need to change that negative 1 to a 0. So I'm going to say 1 times row 2 plus row 3. Now, once I do that, look at the math and look at what's going to happen. So the 1, negative 1, negative 2, 2, the first row does not change. The second row does not change. The third row is the one that's going to change. Look at what happens. Negative, or 1 times row 2, which is 1 times 0 is 0, plus 0 stays as a 0. 1 times 1 is 1, and 1 plus a minus 1 is 0. 1 times negative 10 is negative 10, plus 10 is 0. And lastly, 1 times negative 1 is negative 1, plus 1 is 0. That's how you know this is infinitely many solutions. It is true. It is not a false statement. That's why in this case, it's infinitely many solutions. So your argument for this is that you are left with x minus y minus 2z equals 2. The second row, you're left with y minus 10z equals negative 1. It is a true statement. 0 can equal 0. This is okay. So now we have these two definitions, or these two equations, and we're going to say then, if I solve for y as being 10z minus 1, I can now go back to my equation x minus y, but in this case, I'm going to put I'm going to put 10z minus 1, and this is minus 2z is equal to 2, which when I solve this, gathering like terms and distributing the negative, because remember that's going to also impact my equation, I'm going to end up with x minus 12z plus 1 equal to 2. And my next step then obviously is to move the 12z. So if I move the 12z and subtract the 1, I'm going to add the 12z, take away 1. I'm going to take away 1 here and add the 12z. My 12z's cancel, my 1's cancel on this side, leaving me the x equal to 12z plus 1. Given that I have now two equations that I can use, since I know that y equals 10z minus 1, and that's from this, I now have x equals 12z plus 1. Any value you can substitute can actually be a solution. The only one that you will not have a solution for is z. So your solution set, and this is what you need to pay attention to, your solution set. For x, it's 12z plus 1. For y, you write 10z minus 1. And for z, z. Because whatever value you substitute in for z will work and will give you a value. Do you want to try one of those on your own, or you think you got this? Keep going?
Sure.
Yeah.
All right, so the process really doesn't differ. This one has a little bit of a quirk. This is the last example I'm going to cover here. Example 3. This is a system with fewer equations than variables. So this is definitely one that you might not be as versed at, and you may have a little bit of a question about how the solution works. So here we go. They're saying to use Gaussian elimination to solve the system. Here's your system. They're giving you 3x plus 7y plus 6z is equal to 26. They're giving you x plus 2y plus z equal to 8. So you notice that we have 2 equations, but we have 3 variables, and that's what they're getting at. Okay, so we begin by swapping or creating our augmented matrix, which we begin with 3, 7, 6, 26, 1, 2, 1, 8. So obviously step 1 is to swap row 1 and row 2. So I'm going to swap row 1 and row 2 so that I have my new matrix, which is 1, 2, 1, 8, and 3, 7, 6, 26. So that's my step 1. I want this to be a 0. So in essence, the best way I can do that is if I multiply -3 times row 1 plus row 2, and I apply that here, then my new matrix is 1, 2, 1, 8, and this becomes 0, 1, 3, 2. So if I translate this, I have an equation already. I have 2 equations. I have x plus 2y plus z equals 8. And I have y plus 3z equals 2. So I can solve for y. I can say y is equal to -3z plus 2. I can do that. And if I plug this into this equation here, so I'm going to plug this y value that I just obtained in here, I'm going to end up with x plus 2 times -3z plus 2 plus z equal to 8. I'll distribute the 2, obviously, and then combine like terms. That's going to give me, initially, I'm going to have x minus 6z plus 4 plus z equal to 8. Okay, that means that I technically am combining those 2 values to get x minus 5z plus 4 equal to 8. I'm going to subtract the 4 and add the 5z. So plus 5z on this side, -4. And I'm going to go -4 and plus 5z. And now I have x equals 5z plus 4. Okay, so there's my solution set. My solutions are 5z plus 4. My y values are -3z plus 2. And my z is just z. Would you like to try one of those?
That's like easier than anything than like all of them because there's just like less
Go
work to do,
for
I
it.
guess.
Just two of the solutions.
Yeah.
Yep. All right. All right, that's it for 9.2. Let me go to 9.3. This is just matrix operations. And this has, I'll tell you how many examples so you prepare mentally. Okay. It is 9 examples. Do you have the heart for it, or you rather do your homework and we'll leave this for Wednesday, Thursday?
Honestly, I would prefer to do it on Thursday because I just noticed that I ran out of pages on my notebook. I just have 1 page left.
That's fine. I think that's a wise idea. I now looking at it in 9.3, it changes the script, so it's a different mindset.
It's gonna be too much.
Yeah, I'm still trying to get this down, you know?
That's what I'm thinking. Just to be fair to you, I mean, I've already tortured you with taught you the trigonometry. So
Yeah, I still need to do the homework for 9-1 because I couldn't do it yesterday. So
that's fine.
Yeah, but
Okay.
seeing this today made yesterday's lesson a lot clearer. Like, honestly.
yeah, because the thing is, we had time to let it soak.
Marinate is what I say. Marinate it.
Yep, marinate, marinate.
So it's fine. It's fine because I think 9-3 is going to take a little bit. It'll take the rest of, actually, it'll eat up the rest of the hour now that I think about it. So go ahead, get to work on the homework or the quiz. You have choice. I'm here. Whatever you need help with, let me know. Is that
Thank you
cool?
very much, Professor.
Okay. Is there anybody on the call here of the 16 of you on the call? Usually it's the faithful ones that are passing with 100 practically. Anybody need to talk to me in a chat room privately about your progress? So you have questions? Any issues? No? Yes? You can chat me.
I have a question unrelated to that.
Uh-huh.
If we're ahead, do we take, is the final exam going to be open ahead or just the same day?
No, final exam the same day.
Okay.
And you'll have me here. You have the options of doing it with me face to face, or you can do it with Honor Lock, your choice.
Okay.
But no, I will open the review for you early.
Okay, just making
So,
sure.
yeah, the review you can definitely.
But my question is, how bad is it gonna be? Because it says now
Horrible.
we're gonna have to do trick and trick.
Terrible. It's
Yeah,
gonna be
I know you're kidding, but I know it's gonna be a lot of work because we already had it before. But we have to remember all that.
you are gonna have to recall the trig, but you saw the trig final was not, or midterm, the trig midterm was not that bad. Come on. Most people
It was
scored.
like a watered down version of like what we learned.
Yeah, honestly, the practice midterm was harder than the actual midterm.
That I guess that's what I meant to say. Like I
that
took
is-
like the practice one and it was a lot harder than the actual one.
Mhm.
It
Yeah,
took
and
me
that's
hours.
on purpose. That's on purpose because that it helps you practice and it makes you a better student. And when you get your quiz or final, whatever it is you're doing, you're better. You know, it's like they say, you train harder than the match you're gonna play. I used to play tennis, and they used to tell me, you know, practice harder than a hard match would be, so that when you get to the match, it's not that hard, not that difficult. So
That's
that's
a
good.
very good psychology trick.
There you go. But now you guys have got this. All right, I'm gonna be quiet. If you want to chat me, I'm gonna go to the chat room. And I'll be meeting with people individually, so you might see me get sucked out.